Hi, and welcome to today's lesson. We're going to discuss congruence transformations. Before, we've looked at whether two triangles were congruent, and now we're going to go ahead and talk about different ways we can manipulate triangles by reflecting them, translating them, and rotating them. We're going to talk about what all that means. We're going to also talk about congruence after we do what's called a congruence transformation. So let's just look at some terms here and get those out of the way. We have on the left here a reflection. Basically, like you think of a mirror, you have something flipped exactly the opposite as it was to begin with. And that line that it flips over, the line that causes that congruence, is called the line of reflection. You have what's called the pre-image, this triangle ABC, and the image which is created from the reflection, which is triangle FGH. And then you can see there they've used this arrow to represent the fact that triangle ABC has been reflected to triangle FGH. The second type we're going to look at is a translation, which basically means we take the triangle and slide it up, down, left, right. And you can see here this triangle JKL has been translated down and to the right, the pre-image, and then we have the image MPQ. And it's the same figure, it's just moved in a certain direction. The final type of transformation we have is a rotation. Basically, when you turn something around a certain point, called the center of rotation. And that center of rotation can be inside or outside of the triangle or whatever we're rotating. In this case, that point is outside. We're going to pretend this triangle is kind of connected to that point, and we're rotating it around like a windmill around this point right here. And this is what it would be as we turn it a little bit clockwise. So let's identify the type of congruence transformation here. Is it a reflection, a translation, or a rotation? Well, since every point appears to be the same, the shape is still oriented, triangle part up and the part down. The size hasn't changed or anything like that. It looks to just have been slided to the right and down. So we're going to go ahead and call that a translation. Second example we want to look at, now in this case we do have a difference in where the points are located. We have the right angle actually to the right of the triangle in this picture, but it's to the left of the triangle in this picture. This tells me that it's probably been twisted in some kind of way. It's clearly not a reflected image in a mirror, and it hasn't just been shifted. So we're going to call this a rotation. So finally, this last image here, you can see now we have, it is turned around, but it appears to be a direct reflection of the image above it. You can see each vertex is the same distance from the x-axis. So in this case, we have the line of reflection being the x-axis. So let's go ahead and one. Go ahead. You need to answer this. Which one does this appear to be? You should have chosen translation. As you can see, it has just been shifted to the right, slid to the right. Go ahead and try to identify this one. Now this time, even though it has been shifted to the right, it's also been flipped, so to speak. So we would call that a reflection. Finally, go ahead and identify this one. And as you can see, it is being rotated. It's not a direct flip. It's not a mirrored image, and it's not only been shifted. It's been rotated. So now we want to identify the type of congruence transformation shown by the image of the bridge in the river. And let me move out of the way here so you can see this image. We have very faint image there, but you can see we've been talking about mirrors. That looks like a mirror image. It looks to me as if that would we would call the line of reflection the line where the bridge meets the water. Identify the type of congruence transformation shown by this piece. Is it being reflected, translated, rotated, or none of the above? You should have translated because it's simply being slid to the right. Move to. So let's look at how we can verify congruence to show that triangles are congruent after they've been transformed. So we have here triangle PQR. It's got vertices 4, 2, 3, -3, and 5, -2. And it's a transformation of the original triangle JKL, which has vertices at -2, 0, -3, -5, and -1, -4. We want to graph the original figure and its image, and then talk about what transformation we see there and whether or not it's a congruence transformation, meaning the pre-image and the image are congruent. So we go ahead and look at the graph here of those two triangles identified. We see just by looking at it, it looks like they're congruent. It looks like a translation to me, but what we can do is we can verify that with the distance formula. So you see here we can measure the distances of JK, KL, and JL to get those three values: radical 26, radical 5, radical 17. Let you work out the math if you need to, but as you can see, for PQ, QR, and PR, the sides of the image, we also get those same values. So that is going to verify for us that each side of each triangle is congruent, and therefore that translation congruence transformation. We know that by, remember our theorem, side, side, side. So go ahead and your knowledge here. We have these two triangles ABC and XYZ. With those points, if you want to use graph paper, you can graph the original figure and its image, and then discuss whether that's a congruence transformation or if the triangle has changed in size. Or in other words, I'm sorry, we're just identifying the type of transformation and verifying that it's a congruence transformation. So hopefully you chose A and saw that when you graphed it, it is indeed a congruence transformation, and it's a reflection of R. And that is actually going to conclude today's lesson. Hopefully kind of brief, kind of straightforward for you. And there's one more lesson of this chapter before complete.